All right, today's aim is let's build an equation for a circle. All right, lesson 4, distances in circles, 4.1, going the distance. So this first part, read what Andre says and explain how Andre can find the legs of the triangle, meaning these two sides that are adjacent to the right angle, not opposite, right? The opposite side to the hypotenuse. And then they also want you to find the distance between P and Q, that is the hypotenuse. So find the distance of those three sides. All right, so explain how we can do that and then find them as well. Okay, I'm gonna jump ahead to 4.2. Right, that'll be answered on Google Classroom. All right, 4.2, circling the problem. The image shows a circle with center 6, 10 and radius 17 units. Number 1, the point 14, 25 looks like it might be on the circle. Verify if it is really on the circle. Explain or show your reasoning. All right, so I'm gonna mark about where I think 1425 is. So it looks like 1425 is about here. So let's assume for now that it's on the circle. So, just like in the do now, I'm gonna try and create a right triangle here. Because if I create a right triangle, I have a formula that can find the lengths of all these sides. So if we're talking about a radius, right, that's going to be the length from the center of the circle to the circumference. So this should be 17 units if everything goes according to plan. Now I need to find the other two lengths. So because this is a right angle, I know that these two lines are perpendicular. So in this case, I'm having a horizontal line. So since it's horizontal, I can easily find its length. Because if I'm starting at an x-coordinate of 6 and ending at an x-coordinate of 14, if I'm going from 6 to 14, right, that's going to be plus 8. And really, I'm finding my change in x here to be plus 8. Right. Now, if I have the other part of the coordinate right, I'm going from 10 to 25. All right, so if I'm going from 10 to 25, that's plus 15. And that's equal to my change in y. So let's label that in the diagram so we can really see what's going on here. 8 and 15. So to verify if this is actually on the circle, this hypotenuse is going to have to be 17 units. So let's see if that's actually true. So I'm going to write my equation for the Pythagorean theorem, right? A squared plus b squared equals c squared. A and b are my legs, so I'm using 8 and 15 to substitute in. C is my hypotenuse, which I'm going to pretend I don't know. So let's see if it actually ends up being 17. If it does, then I know that it's got to actually be on the circle. So 8 squared is 64. 15 squared is 225 equal to c squared. 64 plus 225 is 289. Now I'm going to take the square root of both sides to get rid of that exponent of 2. And the square root of 289 is plus or minus 17. Since we're talking about a length, I only want the positive answer. So just 17 is equal to c, which ends up being the same as the radius. So I know that this has to be on that circle. It fits perfectly with what I already know is true about this circle. The point 22, 3 looks like it might be on the circle. Verify if it is really on the circle. Explain or show your reasoning. All right, let's do the same exact thing. So I'm going to go to 22 on the x-axis and up to 3 on the y. And that looks like it's about right here. All right, so again, it looks like it's probably on the circle, but we want to make sure that it really is. So again, I'm just going to erase this 8 for now because it's sort of in the way. Let's see that should be 17 if everything goes according to plan. Since that's my hypotenuse, I know that I'm going to have a right angle over here. All right, and this actually is not the only right triangle you could have drawn. You also could have drawn a right triangle like this. As you can see, the hypotenuse here is the, let me erase that because it looks a little sloppy. The hypotenuse here is actually the diagonal of this rectangle that we've created. And if you remember from our quadrilaterals unit, the diagonal of a rectangle will create two congruent triangles, so these triangles are the same. Could have done the same thing up here, right? I could have made my triangle, right triangle like this, and I also could have found it out the same way. All right, but let's try this here. So again, I'm going to stack my coordinates. So we're starting at 6, 10, going to 22, 3. All right. So if I want to find this this side of my right triangle, this lower side here, that's horizontal, so that's going to be a change in x. So that from 6 to positive 22, that is plus 16. Right, so that's my change in x. 10 to 3 is my change in y. And if I'm going from 10 down to 3, that's actually a negative change in y, so that's a negative 7. And we can see that we are going down here, so that makes sense. So now we're going to do the same thing. Normally, I would say it doesn't really make sense to have a side of a shape being negative, but since we are talking about the coordinate plane, you can have negative things, so I'm going to stick with it. You'll see in a second that it doesn't actually matter if I chose positive or negative 7 here. So I'm going to write my Pythagorean theorem again. A squared plus b squared equals c squared. All right. One of my legs, the bottom leg here, that's 16. And here I've got sort of a negative 7. And right, when I plug these two numbers in, when I plug 16 in for A, or when I plug negative 7 in for B, if I square a number, right, it just means the number times itself. So even if I had chosen positive 7 times positive 7 is the same thing as negative 7 times negative 7. So in this case, it really doesn't matter if this number is negative or positive. I'm going to pretend I don't know this hypotenuse. I want it to be 17 though, because then that means it would be on the circle. If it's not 17, I know that the point is either too far from the circumference or too close to the center. So let's see if it works out. 16 squared, I think is 196, but I'm going to double check. 256, good thing I checked. I think that's 14 squared. 7 squared is 49, or I mean negative 7 squared. And it's very important that you put parentheses around here. If you notice when I put in my calculator, if I just do negative 7 to the power of 2, I get negative 49. And if any of you remember from the exponents unit last year in algebra, whatever the exponent touches is what gets squared. So in this case, only the 7 is touching the squared. The negative sign is technically not being touched by this exponent. So it's doing 7 squared and then making it negative. If I put parentheses around negative 7, I'm squaring all of this. I'm squaring negative 7. So this is doing negative 7 times negative 7, and then I'm going to get positive 49. So it's very important when you're squaring numbers that you put parentheses around them, especially if they're negative. So here we go. 256 plus 49. 305. And already I can tell this is not going to be on the circle. How can I tell that? Well, last time we had c squared equals 289, and that ended up being 17 perfectly. So if I square root this, I know it's going to be more than 17. And just to verify, I'm going to show that on the calculator. All right, we get 17.46. So this point's going to be a little bit off the circle, not quite on it. All right, so c does not equal 17, or really c is equal to 17.464. And that's going to go on forever. It's an irrational number. So it's not on the circle. In general, how can you check if a particular point is on the circle? All right, well, we need to know the center, right? We needed to know that 6, 10 was the center. you need to find the change in x and change in y of x comma y from the center of the circle. Right? Then what did we do next? What did we do with this change in x and change in y? Well, we squared both of them and then found their sum. You then square, well, I'm going to write it out in math because in words it sort of looks weird. Square change in x and add that to change in y. And that's going to be equal to, well, where do we plug 17 in, right? That was a hypotenuse, but really 17 is also the radius of that circle, right? From here to here, that's halfway, right? From the center to the circumference, that's a radius. So that's going to be equal to my radius squared. Then solve for the radius. If these two sides are equal, then I know that this point must be on the circle. So we can use the Pythagorean theorem to really understand more about whether or not points belong to a circle. And you'll see, since we have x and y here, really we're starting to get closer and closer to an equation for a circle. And that's really the aim of today's lesson. All right, great. So we're on to Are You Ready for More? All right, I'm going to make a new video for that.